to the right, or did it go to the left? We went to the right,
We did.
because we took CO2 and we put it into the equation.
Oh, yeah.
So we started here, we can't get any farther to
Yeah, I
the
forgot.
left. So we took CO2 and we shifted it this way. So we gave up CO2, we put it into the equation. Does that make sense? We're not shifting on the pH scale, we're not talking about the pH scale. If we're talking about the pH scale, we shift it to the left. But we're talking about the buffering equation. So we shifted to the right. These two things are different, so we're going to shift opposite directions. So does that lab make sense? Yes. We had a base, we had to neutralize it. How do we neutralize it? We can use the respiratory system, and we blow off carbon dioxide. When we did that, we added an acid into it, that neutralized it from 9 to 6. And now we're back in a healthy range, or we have to be 7-ish. But in this experiment, we saw a big shift. And we shifted to the right. We added CO2 into it again. So that's the lab test questions. First is, in this experiment, with the experiment with sodium hydroxide, is what we use with the yellow lid. What is this? An indicator. Phenolphthalein is an indicator. If it's purple, it equals base. If it's clear, it equals acid. That's the kind of questions they'll ask about phenolphthalein. And they'll say, in the experiment with sodium hydroxide, what did you use this for? Indicator, color changes. In the experiment with sodium hydroxide, what did you use as a buffer? CO2. The respiratory system was what we used for that. All right. So everybody on board with that?
Mm-hmm.
Great. Our other buffer, other physiological buffer is our renal system, which is the kidneys. And another word we use for that is the metabolic. So renal and metabolic go together when we're talking about buffering systems. So now we're on this side. We're either going to be an acid, and anything having to do with the lungs is going to be using CO2 to buffer. So that's an acid thing. Everything else is going to be regulated by the kidneys, and the kidneys are going to use bicarbonate, HCO3, to act as a buffer. And where we store bicarbonate is in our kidneys. It travels throughout our blood, just like CO2 does, but it's stored in the kidneys. So now we're going to buffer using the kidneys, and this is a metabolic buffer. So we're going to do an example of this. And what we're going to use in this one is a common reaction we've all done before, is vinegar and baking soda. So bicarbonate is going to be sodium bicarbonate is our baking soda. That's what we're going to use as a buffer to pretend like we're the kidneys. It's as close to bicarbonate as we can get. So we're going to use, you'll have a little white vial or jar of baking soda. All right, so measure out, dump out your stuff.
Let's do that.
And then when you dump that out, put 25 mils of water in it when you come back. So dump, come back with 25 mils.
You want to take the cross?
Oh, yeah.
So it's pretty cool stuff. It's interesting to see. 25 mils of water. So come back, bring your water back. We have 25 mils in there. number 1 plus the pH of water is still 7. It's still neutral. And then measure 5 mils of vinegar, also called acetic acid. Put that 5 mils of vinegar in your graduated cylinder.
You want it?
5 mils of vinegar in the graduated cylinder. And then pour it in the water. And then measure that pH and see what happens.
Really?
Whoa.
That's what happened.
Yeah.
And what's our pH? Should be about 2 or 3. Which we already know, we measured that. We already know water is neutral at 7, vinegar, pour that in there. Vinegar should be around 2. So we know that's very acidic. So 7 and 2, for 1 and 2, 1 is 7, 2 is 2. Now we have a really acidic situation. Now we can't have that. We've already used protein to buffer. If we were using that protein powder, how would protein act this time? As an acid or a base? It acts as a base, because we're already in an acidic situation. We need to bring it up. So, and we've already used the lungs, we've used the respiratory system. So what happens is the respiratory system and the renal system compensate for each other. If one's out of whack, the other one picks up the slack. If the lungs can't do it, the renal system will do it. If the renal system's not working, the respiratory system will do it. We always have lots of protein in our system, so they can do that. We have other phosphates and other things that can chemically buffer.
Is there something that's preferred first, like do the lungs always pick up first?
The lungs are the easiest one,
Okay.
because it's easy to change
Just
respiratory.
depends on the situation. Okay.
So physiological buffers are going to take a little bit longer to work, but they're going to be 3 times as more powerful as chemical buffers. They're going to be longer lasting, and hopefully they're going to fix the problem. So it takes a little while longer. Respiratory is pretty easy to regulate, but it's going to take a little bit to get everything balanced out with our breathing. So we're down here at pH of 2, very, very acidic. So how we're going to neutralize this is we're going to be the kidneys, and we're going to use bicarbonate. We're going to use sodium bicarbonate, which is baking soda. So we're going to add a heaping teaspoon of baking soda to our mixture and see what happens.
Ooh, you like baking soda?
Not like clean,
Oh,
Yeah.
yeah. I thought you were meant to eat.
I need some baking soda.
Ew.
So what happened?
Bubbly.
Bubbles. We gave off a bunch of gas, didn't we?
Yeah.
Way to clean it too.
That's a good way to clean, yes. So the bubbles added lots of hydrogen. And this time, which way did our reaction shift? We took bicarbonate and we shifted to the left. So we took this and we added it in. So in this situation, we shifted to the left.
Oh.
And then measure, see what your pH is.
Oh yeah, move that straight.
Can you hand me the strips?
There you go.
Just tilt it over.
What do you think? Eight, yeah. Oh, pretty good, 8.
7, should be about 7 or 8. 7 or 8. So we went from 2, and we brought it all the way up to 7 or 8. That was a pretty powerful buffer, wasn't it? So that's how strong the kidneys are in buffering things. The kidneys can really buffer as well. So we went from 2 to, we'll say 7. And in that equation, in our buffering equation, we shifted to the left. So we took the bicarbonate and we added it in, and we came back here to neutral. So we shifted, in sodium bicarbonate, baking soda, we shifted to the left. And we were simulating the renal. Yeah, so when you're thinking about this, you can't think about both things at the same time. you have to think about the equation, which way are we shifting, or the pH scale, which way are we shifting. So if you're getting confused, that's where you're getting confused. So pH shifts one way or the other. What we just did, we went from 2 to 7, so we went to the right. So that's not what the question is. It says, in this reaction, which way did we shift? We used bicarbonate, we added it in, we shifted. So these two things are different. So pay attention to which, if it says on the pH scale, which way did we shift, up or down from 0 to 14? Or in our buffering equation, which way did we shift? That's what'll mess you up. All right, so that's how the kidneys are buffering. It says, why did bicarbonate, HCO3, have this effect on pH? Because we added in the bubbles, right? We put in a buffer, and we neutralized it. And it says, which way did the reaction shift in the equation? To the left. We took bicarbonate and we added it in, we shifted to the left.
In the first one, you should have done two.
In the first experiment, we
What body
went
compartment? Where do we store
from
HCO3 bicarbonate?
neutral
In the kidney.
to basic with the milk of magnesia. The
And then
milk of
below, why does it
magnesia,
constantly need to be
adding the other
replenished by
thing,
kidney?
we shifted to the left, back
We're
towards
always
acidic.
buffering, always buffering, always buffering. Why do we need to constantly breathe? Because we need oxygen, right, because we gotta stay alive. So we're going to, we'll talk about that in the lab, and then we're gonna pee it out, that's what the kidneys are doing, or we're gonna hold on to it. So we're always replenishing that. All right, so let's review. Any questions, first of all?
I got a quick question.
Yes.
So, with regard to the reaction shifting,
Yes,
is it always going to be the opposite of the?
very good. Good.
Okay.
So the first reaction shifted to the left.
Which reaction?
Precipitate
I'm sorry, the first one that we
Yep.
did,
or precipitate.
respiratory
And the respiratory shifted to the right.
to the right.
Right here, respiratory.
And
And the
it's
reaction,
very
how they
clear
worded
that
is
it
that the
became
reaction
more of
with
a
sodium hydroxide.
colloid.
I don't know which experiment I'm talking about.
It's still
We
got ions,
used
so
the
we consider it
respiratory
a
system, that's
suspension.
when we blew in carbon dioxide, and we shifted to the right. So sodium hydroxide, we shifted to the right. What we used as the buffering was the respiratory system, because we blew in CO2. And then the last one, in the experiment with baking soda and vinegar, what did we use as a buffer? Bicarbonate, baking soda, sodium bicarbonate. And in which direction did that reaction shift?
Shifted to the right.
And then it shifted to the left. And that was our renal system / metabolic.
That equation will always be written in that order.
Yes. And see how the arrows go both directions, so we can shift. We can go this way and we can come this way in all parts of that reaction. And that's what we're always doing. We're always buffering, always in homeostasis. It's not a static environment. It's always up and down, changing. So we're always going to slide back and forth in this equation. Respiratory, CO2, bicarbonate, renal. All right. So that's a really complicated lab. There's a lot of chemistry involved in that. But that's the main idea, is we need to stay in neutral territory, and how are we going to get there? We're going to buffer. The first way we did was we used the protein powder, that's a chemical buffer, and proteins can act as acids or bases, whichever way they need to go. The reason they can do that is because they have that NH2 group up on top, and we can give away a hydrogen, or we have a spare hydrogen and we can add it to it. So we can donate or we can accept. So proteins can go either way. Down here, we're looking at our physiological buffers, the respiratory system, blow it off to get rid of acids, or hold on to it, slow down your breathing to accumulate acid and bring your pH back to normal. So speeding up breathing or slowing down breathing, acting as an acid or a base. The renal system, we're going to hold on to it, or we're going to pee it off. And what we're holding on to or peeing off is the hydrogen ions. and it's gonna go out. It's like the whole ADH thing, do we wanna hold it or do we wanna let go of it? So the renal system uses bicarbonate, which is acting as an acid or a base, and so we're always shifting on this equation. And what we're doing when we're shifting is we're affecting pH. We're gonna slide up and down that scale, we're gonna try to stay in the neutral territory. So what might be some things that would make you very acidy? What might you do? Salsa. Tomatoes, citrus things. What about alcohol, acid or base? Acid. Very acidic. So this is what happens with binge drinking. That's why people die from binge drinking, is they get so acidic, they go down the scale and everything slows down and they go into a coma. And you're like, oh, they're just passed out, they're just sleeping it off. And then you go to check on that person and that person's died because they've gotten into acidosis. And we can't exist that far out of range. So that's what can happen in that situation. And you think, oh, they're just sleeping it off, just let them go. And we hear about that all the time, right, with people dying from that. So it's an acidosis situation that they get in. Diarrhea, not a nice thing to think about, but if you have excessive diarrhea, food poisoning, you have the flu, think about it's very acidy feeling, right? And so you're getting yourself into a dangerous situation with that. How about a basic situation? What's going on there? How might we get too basic? What might we be consuming on a regular basis?
Too many times.
Too many tons. The reason you have heartburn is not because you have a Tums deficiency, right? Or a Prilosec deficiency, or a milk of magnesia, or whatever. There's a reason that you're making too much hydrochloric acid, so you have to figure out what that is. Digestion, which is the next chapter we do, is $1 billion industry in the US, because everybody has digestive problems. And then we can get into a basic situation, because we're trying to neutralize it, it hurts. We don't want to have heartburn, so we constantly rely on Tums or whatever, Prilosec, whatever, and then we get ourselves into a basic situation, and then you feel bad in a different kind of way. So that's also a situation, or vomiting. Same thing, flu, food poisoning, whatever. So depending on which end it's coming out, are you gonna be acidosis or alcohol situation.
So why do pregnant women always get a lot of heartburn?
Because the baby's pushing up on the stomach, and then it just refluxes up into the esophagus. So it's just too much upward pressure.
Okay.
Yeah. And then when you lay down, what happens? If you're standing upright, gravity is working with you. So here's the stomach. We have the sphincter there that keeps the stomach closed between the esophagus and the stomach. And when we're upright, gravity is working with us. So everything's supposed to stay in the stomach. As soon as we lay down, we go like this, and it can trickle up. And then you're like, oh, I can't lay down. So people sleep with 2 pillows, or they'll sleep in a recliner. And then you get back up, you're like, oh, that's much better. You lay back down, oh. So it's that sphincter that's not closing completely, and then that fluid can leak out of that. And the stomach's made for the pH of 1 or 2 hydrochloric acid. The esophagus is not made for that. The esophagus is made of stratified squamous tissue. The stomach is made of tissue that can handle a really strong acid environment. And that's why it burns so much. The stomach can handle it, but the stomach gets ulcers, right? If things go wrong, that acid starts eating.
The gallbladder, when you get like a gallbladder attack, is that because you have too much acid?
That's a bile situation.
Okay.
Yeah, that's more of a bile situation. Now, spicy foods and acids can irritate it,
Yeah.
but it's a bile issue. What can be irritating, it can be those acidic things. So you stay away from fried foods, fried fatty foods, spicy foods, because those aggravate bile conditions. All right, one last part to do of this lab. So does everybody feel pretty good about that? Take your pictures of that if you want. And you have this little flow chart. This is your last page. You have this little flow chart. So now that we know we can get in an acid state or a basic state, we want to apply our information.
Yes.
Acidosis is we're in a state of too much hydrogen. We're on the top of page 90. So we're less than 7.35, right? Normal pH, 7.35 to 7.45. So, 102, sorry, in the old book, 102, 103. So acidosis, we're below 7.35, or we're the opposite way, alkalosis, we're greater than 7.45. So we know our pH is out of balance, but why is it out of balance? So the two indicators that we're gonna use is carbon dioxide. We're gonna look at normal ranges there. If we have too much, we know we're in a state of respiratory acidosis. That makes sense, CO2 is an acid. If we don't have enough of it, we're gonna be in respiratory alkalosis. Then we're gonna go over and look at the other side. We're gonna look at the renal system. We're gonna look at bicarbonate. If it's not CO2, it's gotta be bicarbonate. So when we're looking at HCO3, when we're looking at our bicarbonate, we're gonna be in metabolic acidosis or alkalosis again. And we're just gonna look at this range and see where are we falling. So under normal blood ranges, we know pH is 7.35 to 7.45. CO2 should be 35 to 45 millimeters of mercury. That's the proper value that we should be at. And bicarbonate should be 22 to 26 milliequivalents. So that normal range is on this chart back there. You don't have to memorize it. It's on your flip chart back there. Those are the normal values. And if everything's within normal range, we're in homeostasis. If not, we're going to be in acidosis or alkalosis. So now we have to determine why are we in that situation. So looking at it, says use the three-step process to use these guidelines. pH is abnormal, so we're not in 7.34 or 7.45. Let's go and look at CO2. So we're going to determine pH is not right. Let's determine why it's not right. Let's look at our CO2. If it's greater than 45, respiratory acidosis. If we're less than, respiratory alkalosis. So CO2, we want to check that out. But we also have to check out bicarbonate. If bicarbonate is greater than 26, we're in metabolic alkalosis. If it's less than 22, we're metabolic acidosis. So those are the values we want to stay in. Now we're going to go over here and we're going to determine what state is the patient in. So first off, let's go and look at letter A, pH 7.2. Are we normal?
No,
No, what are we?
we're going slightly acidic.
We're acid. So next to 7.2, write acid. Just right above, you might want to write your normal values here. pH should be 7.35 to 7.45. CO2 should be 35 to 45. Bicarb should be 22 to 26. Okay, so we know we're in an acid state. Our CO2 is in 50. Whoops, that's not a range. That's not right. So we know we're going to be in an acidy state, right? Too much CO2. And then let's look at bicarbonate, HCO3. That's at 24. That's normal. So the bicarbonate is buffering us. So now we go back here and we use the chart. And I'll give you the values. You guys look at the chart. So we got to use this chart to determine what kind of acidosis or alkalosis are we in. Our pH is 7.2. So use your flow chart, follow that. We have low, so we're going to shift over to the low side. And now it says check what your CO2 level is. Our CO2 level is 50, so follow that chart. It says high, and then what does it say below that?
Respiratory acidosis.
All right, but we're not done yet. We got to check our HCO3, and it's at 20.
It's a normal range.
So we're normal, we're not high. So the proper answer for this is we are in respiratory acidosis with no compensation.
With no compensation.
Is that what it says?
Yeah.
Yeah, no compensation. So you just use this flow chart, you just keep going. You need to check three things, your pH, your CO2, and your
Respiratory compensation.
Let's go look at the next one. 7.7.
We're basic.
Ooh, we're basic.
We're real
Why
basic.
are we basic? CO2 is 50, so let's go, our pH is too high, so follow that over to the right. Our CO2 is 50, so we're going straight down. So we know the respiratory system is compensating, but we're not done yet. Our HCO3 is 29.
Could be partial because the pH is already
So we're in metabolic alkalosis. Everybody using the flow chart?
You say B or C?
B. Letter B. So we follow down, we're in metabolic, we're in, our HCO2 is very high. It was 29. So we're in metabolic alkalosis with respiratory compensation. Everybody see what I did there? All right, let's do C, 7.30. Well,
Yes.
we're a little bit low, so let's follow that. Go into the left. You guys work on it, see what you come up with. CO2 is 40.
So it's normal.
Metabolic
Acidosis.
and bicarb is 20.
That's 20. Metabolic acidosis.
Also, we're doing it so what are we in?
Metabolic acidosis.
With?
No respiratory compensation.
Very good. No, no. Okay, let's look at the next one, letter D, 7.4. Oh. Well, we're normal, aren't we? pH says we're normal, but we're not done. We have to check CO2 and bicarb. CO2 is 50. Ooh, that's high. Bicarb is 34. Well, that's high too. Where are you at? On D? Oh, 50 is.
Here, 38, 50, 38.
You have a different one than me.
38 and 15.
Okay, please switch it. Okay, well, do yours then. 38 and 15. So we're normal, CO2 is 38. Respiratory compensation. And what was it?
15.
15.
So where do you go
No,
from
the
here? There's nowhere to go.
The respiratory system is
So
compensating.
you've got
So we put normal
We had normal.
So we have normal.
with respiratory
Check
compensation.
CO2.
So we're not
up
really
here.
in
So we gotta check
balance.
your CO2. Where is
But
it?
if we just look at the pH,
Is
we
it
are.
high or low?
If we look at
It was,
carbon dioxide and the bicarbonate, we're out of balance. But the
It's
respiratory system is doing the
normal.
job and it's
Okay, so
keeping
your
us
CO2 is
in
normal.
pH.
Okay.
So
What
that's why you have to look
about
at all three
your,
values.
It's abnormal.
It's abnormal?
Work on the next couple,
So-
thank you.
We are, if our, it's not a respiratory, then it's our metabolic alkalosis.
Metabolic acidosis. Is that what you said?
No, alkalosis. It's the one slightly alkaline, this HCl is slightly alkaline. Then you know that it's metabolic alkalosis because you're slightly alkaline, you're slightly basic.
I guess I'm trying to follow the flow chart. That's what's throwing me. If you go all the way down here,
The second one.
where do you go? I mean, you know what I mean? It
Right,
stops there.
yeah.
So how do you know where to go? I can understand if it was here, then you just follow the arrows either there or there or there. But there's nowhere to go from here.
Right. I just know if the one's slightly off, that it's gonna be that one, whether it's up or down. You know what I mean?
This would be about 25.
Because I think of
These are all say normal range.
7.3 to 7.4 is normal, right?
Yeah.
And if I know that this value is messed up, I know that it's gonna be metabolic alkalosis. Because it's not respiratory, it's not the lungs doing it, the lungs are normal. The renals are putting off more of that bicarbonate.
Okay, so with compensation or without, how do you know?
You know if you're compensating, if your breath changes.
So because pH and the respiratory was fine,
Yeah,
then it's without compensation.
right, it's not compensating for anything, it's not out of range, now is it?
No,
How can it be compensating if it's just doing what it does?
yeah,
That means that you got something going on with your kidneys, it's just your kidneys and your, what picks that up?
No renal compensation?
Yeah.
How many things like this, like